Hello everyone, my name is Nana Tian and I'm currently a PhD student from the Immersive Interaction Group at EPFL. Here I will present you our study on the effect of vertical axis alignment on cyber sickness and game experience in a supine posture. First of all, as you can see from the title, our main topic is cyber sickness, still the inevitable problem in virtual reality experience. In general, it is an adverse effect that can occur during a VR experience, leading to unpleasant symptoms such as nausea, dizziness, and headache, etc. We all know that VR technology is developing so fast in recent years and has been adapted to different fields. Typically, the user often plays either standing or seated when experiencing VR. However, it can be necessary to confine individuals to the supine posture when it comes to studying human brain phenomena with VR settings, such as monitoring participant brain activities using fMRI. More importantly, investigation of function-induced nausea with fMRI and gastro measures could probe essential brain-gut and gut-brain interactions related to nausea. They may also necessary to apply VR in a lying down posture for rehabilitation or entertainment purposes of the disabilities, etc. Recent studies have identified several factors that could potentially influence cyber sickness, and posture is among one of the key factors. According to the review, a majority of papers have focused on cyber sickness in either seated or standing posture. So naturally, people will think of which posture is the most comfortable, or in other words, the least cyber sickness inducing. It is well known that a player will feel less cyber sick when seated. A paper from Julian Marigold et al. Indicating that people are more sick in the supine posture than the seated one, even the experienced users. So we're wondering why. Clearly, the head orientation is a marked difference between seated and lying down posture. Previous neuroscience studies indicating that even though the vestibular system are not, or at least not fully active during VR exposure, the directional information, such as head orientation, provided by the vestibular system is always active and present. Hence, our assumption is that different sensory systems receive different coordinate information may lead to cyber sickness. Together with our assumption, we further propose and formulate a possible explanation into one kind of sensory conflict, that is a disparity between visual cues indicating the upward direction in the virtual environment and audiothetic cues indicating that the user is in fact lying down physically in the real world may result in more severe cyber sickness. Subsequently, we named the associate factor as the virtual vertical axis orientation. We will reinforce the factor in the following slides. Okay, now let's sum up. The main goals of this study are threefold. First of all, to investigate whether specific game design without identified conflict could mitigate cyber sickness in a supine posture. Secondly, we also thought of taking this chance to explore the most comfortable game design for the lying down posture. Hence, we introduced a second factor as a game type. Finally, we want to see how different game designs perform in terms of user game experience. With these goals bear in mind, now we move on to the experimental design. First, I want to talk about the two levels of the virtual vertical axis orientation factor. As you can see, the left design is the original design from the Marigold's paper, and on the right is a new design that we proposed. So on the left, even though the virtual world vertical direction is aligned with the body spine, however, as the inner ear keeps sensing the lateral environment, the real world axis which is displayed in the middle, will conflict with the axis that people see. So with such assumption, we want to maintain the consistency between the real and virtual world axis, which result in the new design on the right side. Also, as aforementioned, in order to find the optimal design for a lying down posture, we also introduce the game type as a factor. As a result, the experiment is designed to be a 2 multiplied 2 within subject factor design. To make it simpler, we use short terms for each conditions. For example, SB is short for static game with body axis design. The static game is basically a simple puzzle game. The player uses a controller to point and link the stars. The dynamic game is also designed to be simple, where the player uses a controller to move to the left or right to collect the blue stars and avoid red stars. Now let's take a look at the two demos of static and dynamic game with the body axis design. For the puzzle game, you have to collect the stars with one stroke. As for consistency, the dynamic game also designed in the same bedroom. Here's a static game demo with a real vertical axis design. The players are looking at the game panel on the ceilings as if they are lying down in the virtual world. As a result, we recruited 30 participants aged between 18 to 27. Among them, 7 are females. None of the participants are experienced VR users. The targeted subjects were requested to obey the following rules: no ingestion of alcoholic, motion sickness medicine, or similar substances up to 12 hours before the experiment. The last ingested meal must be at least 2 hours before the sessions. Since it's a within subject design, each participant will go through all the sessions. The experiment takes place over the course of 2 different sessions of around 45 minutes each. Each session is conducted on 2 different days, with a minimum interval of 1 day and a maximum up to 3 days. For each session, a participant plays both of the games with the same virtual vertical axis design for 3 minutes. A mandatory 5 minutes break in between is required. Participants always started with a static game. During the sessions, we use simulator sickness questionnaire and game experience questionnaire to measure the cyber sickness and game experience. After the data collection, we produce the absolute and relative pre-post SSQ scores. This table represents the mean and standard deviation of the obtained data. From the relative results, which is the difference between pre-post scores, we can simply observe that the SV design scores the lowest and DB condition scores the highest. Similar to the previous studies, a higher tendency of cyber sickness was observed in games with acceleration when compared to the condition without. Through the statistical analysis, we find significant differences between SB and DB conditions, also between DV and DB conditions. No significant differences was found between the two static game designs. In conclusion, we find that the new design is effective to mitigate VR sickness in a lying down posture, especially for games with acceleration. We also confirm that these static games are less sickness-inducing. This is in line with the findings in previous papers. From the results, we have some insights to design games for lying down posture, which could be used for rehabilitation purpose or medical studies. Also, it is worth to mention that this experiment showcases the importance of collecting information about the subject's pre-stats of health before they intervene, because we find people's pre-SSQ score are high to consider as sick. For example, the DV condition actually has the highest average pre-SSQ score among all. The statistical result of the GQ total score did not show any proof that one posture outperformed the other. Regarding the game type, people show significantly more interest in the static games than the dynamic ones. However, the results are only applied to our specific designs. It is assertive to conclude that static games would provide a better game experience than the games with movement. Our correlation analysis results agree with the findings in previous literature that cyber sickness and fun are negatively correlated. Overall, there are some limitations in this experimental design, especially for the DV condition. During the interview, some participants reported that they came in with certain degree of fatigue. It is important and difficult to obtain detailed information without implication of symptoms like fatigue, eye strain, headache before the experiment. Ideally, if we had large numbers of samples, we could perform a screening of participants before the formal experiment. Secondly, the average time of being in acceleration or deceleration states was short, which could mask the difference between both static and dynamic game variations. Lastly, we mainly apply the subjective measures. As a follow-up study, it could be interesting to use physiological measures as well. To sum up, in light of the sensory conflict theory, we propose a new conflict that may potentially lead to cyber sickness when users experience VR in a supine posture. In order to investigate our assumption, we implemented two kinds of VR games, one in which the virtual coordinate system is aligned with the real-world coordinate system, another one in which the virtual vertical direction is perpendicular to the real-world one. Also, leveraging the findings in previous studies that visual acceleration can escalate the sensory conflict between visual and vestibular systems, we introduced the static and dynamic games to explore whether such a game design factor could mitigate cyber sickness for a lying-down VR game experience. Results indicating that aligning the virtual and the real-world coordinate system is effective in mitigating VR sickness in the supine posture. Additionally, games without acceleration or deceleration presented a less sickness-inducing experience for participants. In other words, game with constant speed, including the static game, could be more comfortable. Regarding the game experience, our results were in accordance with the previous findings that there is a negative correlation between the degree of cyber sickness and a positive gaming experience. Moreover, even though using the pre-SSQ remains disputable, our experiment showcases the importance of collecting information about the subject's state of health before the experiment. Namely, there is a need to come up with optimal examination of the preconditions of health without implying participants of the possible sickness that they might experience in the following up experiment. In the future studies, it could be interesting to explore different types of interactions and navigation methods to improve the game experience and mitigate cyber sickness while taking the characteristics of such a special user pose into consideration. Thank you for your attention. Any questions?